If you were to go to most enterprises who have been studying how they are going to use AI for their own benefit, what they would tell you is that their data storage or their data itself is so fragmented around the enterprise, they don't understand how they're going to get access to it and pull it together to pull insights out of it.
And there's this move towards slow thinking, slow reasoning models and inference versus fast thinking, GPT-4 kind of instantly give me a result.
Yeah.
How does that affect you when you're talking about much better performance and being able to offer you the solution very quick? Doesn't that fly in the contrast of what you're saying?
Networking, it's like roads and highways. It's something that we perhaps don't give much thought to these days, but is so important in terms of the way that we live our everyday lives, that we can't imagine life without it. Networking is my background. I said, well, how dumb is this? I mean, why aren't these things, why doesn't it operate like a cloud of data? Rather than individual arrays, right? So instead of that external hard drive, why not take the enterprise? Why not allow them to make their own cloud? Why do they have to go to the cloud to get cloud? Cloud is a way of operating, not a destination.
This is TechSurge, the Deep Tech VC podcast presented by Celesta Capital. Each episode, we spotlight issues and voices at the intersection of emerging technologies, company building, and venture investment. I am Sriram Viswanathan, founding managing partner at Celesta. If you enjoy TechSurge, now is a perfect time to hit the like and subscribe button. And while you're at it, you can leave us a review on your favorite podcast platform. If you're just discovering us, visit techsurgepodcast.com to sign up for our newsletter and check out the archive of some very interesting past episodes. Today, we're diving into one of the most fundamental aspects of our digital world, storage. Joining us today is a true industry leader, Charlie Giancarlo, a dear friend of mine from a long time, who's the chairman and CEO of Pure Storage. Charlie is a true Silicon Valley legend who has helped shape the very fabric of the modern internet during his career. Charlie has been at the helm of some of the biggest technology shifts over the last 30 years, from his long tenure at Cisco, where he pioneered foundational networking technologies, to his role in Silver Lake as an investor, and to his various boards, including Accenture, Netflix, Arista, and others. And Charlie is truly a person that can represent the current pulse of Silicon Valley. And so, Charlie, thank you for joining us in this podcast. It's an honor to have you on this.
Well, thank you, Sriram. It's a real pleasure to be here.
Yeah. So, Charlie, you and I have known each other. I was just mentioning prior to the podcast to one of our colleagues that you and I have known each other since 1999.
Yes.
You were at Cisco at that time, and Cisco and Intel and Microsoft had gotten to close to 500 billion, slightly above, in that period. And you really were instrumental in shaping the internet for the next 15 plus years. And you came into Cisco through an acquisition that Cisco made called Kalpana. Can you talk about that first and how that helped shape your career into Cisco and how it evolved from there?
Yeah, so Kalpana, prior to Kalpana, I'd started a company in Silicon Valley that worked on what at the time was high-speed switching and networking. And we actually had built a couple of products, one of which became the first, and again, this is all in the context of the early 90s, the first high-speed backbone for what was then still a very private government-sponsored internet capability. And when I sold that company, I went to Kalpana. Kalpana had an early technology that eventually became Ethernet switching. Believe it or not. So now I'm really aging myself.
And me too. I remember all of it and I can relate to it.
Yeah, so Kalpana actually developed the first, literally the first Ethernet switch. And several years later, we were acquired by Cisco, which was great fun. And of course, with the Cisco engine that existed at the time, just an incredible sales engine, very strong technology in the area of networking and routing. we were really able to expand that switching and routing environment very, very rapidly. And of course, the internet started to become known to the greater public and to organizations after it became a public entity in the mid-90s. And it was just an incredible period of growth. Alan Kay, who was one of the inventors of the early personal computer, had a phrase, which was that perspective adds 40 IQ points. And, the perspective that we had was that the internet would eventually take over everything. And so that really led, and that's how you and I came to know one another. It led to a lot of consolidation in what was then a fragmented communications world. As every type of communication started to be consolidated onto internet protocol, right? That's the 40 IQ points. You didn't have to be a genius. You just had to be have that perspective that everything would collapse into the internet, and that drove a lot of our activity. Now, I have to be honest. We were able to predict a lot of things, such as all communications going onto the internet. We didn't predict Facebook for sure, and what all the social consequences would be of having this ubiquitous environment. But
just double clicking on that, and we'll talk about Pure and some of the other things. But at that time, in the early days, one could argue that Cisco got made because of two acquisitions that happened. One was yours, Kalpana. And the other was Crescendo.
Correct. That's right.
And Jayashree,
your
colleague,
that's right,
came from Crescendo.
That's exactly correct.
And switching and routing effectively made Cisco what it is. So you seem to have picked the right sort of inflection in the evolution of telecommunications and sort of networking at the right point in time. And I want to draw that parallel to Pure. But before we get into Pure, that journey in your mind, is that still evolving? I know that Cisco has got its own challenges and things have changed, but where do you see Cisco's role in the networking space as they move forward? In the data center and the enterprise, there are lots of others that seem to have sort of ridden that wave much better than Cisco has. So now that you're beyond the statute of limitations, you can talk about Cisco.
Of course, when your alma mater falls on hard times, it affects you. It affects one personally, right? One never likes to see that, right? I do think that let's start with the industry itself. Networking, it's like roads and highways. It's something that we perhaps don't give much thought to these days, but is so important in terms of the way that we live our everyday lives, that we can't imagine life without it. And so I think that business, while like roads and highways, we don't think much anymore of when a new one comes in or how instrumental they are, but the ongoing development of that area is incredibly important. One of the things that has become so important is that a lot of the competition, a lot of the new technology has gone into the way that modern data centers work. In particular, the hyperscalers could not operate without these incredibly high-powered Ethernet switches in particular. So when at Kalpana, when we produced our first Ethernet switch, it was 10 megabits per interface. So that is 10 million bits per second per interface. The current state of the art is 800, almost a terabit per second, which is it's 100,000 times faster than what we produced in the early to mid 90s. So it's just incredible. So let me just sort of step back, since you brought up the data center. It sounds like the first wave of evolution of the networking really took advantage of the internet, took advantage of computers getting connected, all of that. But now it sounds like the second wave is really the evolution of the data center. Correct.
And the move towards the cloud. Can you talk about the three pieces, the compute infrastructure, the networking infrastructure, perhaps the storage and memory infrastructure, and how do these things fit in? And which one has sort of the sort of the pole position in driving this innovation forward?
So you're exactly right. I've always thought about the data centers having three core technologies, right, or infrastructures. Compute infrastructure, which has been up until very recently largely Intel-based, your alma mater. The second is the switching environment, right? And by the way, the capital spend also kind of goes in this direction. So then you have the switching environment by which all of these Intel computers, largely Intel computers, are held together and communicate with one another, and communicate, of course, with the applications and the consumers that are getting access to them. And then the third one is the data environment, which has to be stored. When people say they store data in the cloud, eventually it has to be stored on something physical, right? There's not literally a cloud in the sky, right? It goes to a data center or several, in some cases, several data centers, and gets stored on a device that is largely today hard disk. In fact, 90% of the hyperscaler storage environments are still largely hard disk. Now, if you go into an enterprise environment, by which we mean, let's say, a large bank's data center, or most large companies that you do business with have their own private data centers, even if they are also in the cloud. In those environments, about half the data now is on what's called flash memory, which is since we're bringing it up for the first time, it's a semiconductor.
Right.
It's a chip, whereas a hard disk is literally a spinning magnetic disk on which data is written. And so the enterprise has shifted. They're halfway through their shift to go to a semiconductor. In the hyperscale environment, it's still about 90% hard disk.
Hard disk, But I think it's interesting you brought up this analogy between compute infrastructure, networking, and storage. In the computing infrastructure, one could say the Moore's law sort of is the pulse of the whole innovation cycle. Metcalfe's law perhaps is where networking is, and you help drive that to its fullest potential. And there is a equivalent storage law.
An equivalent storage law. So let's go through it. So Moore's law to review for chips is roughly a doubling of density every 2 years, right? You know this. Metcalfe's law was actually a tripling of performance every 2 years. So it was even a faster transition. Over the last,
when you say that in terms of tripling in performance, you really mean the raw bandwidth speed between
systems, right? So when actually I was in high school, there'd be, I think it was 75, what was called 75 baud modems. That was 75 bits per second.
I hate to admit, I know it.
You would hear it, right?
Yes,
you
could hear it.
And then if you go up all the way through access, that people at home, normal people get a gigabit now a second, which is huge. And if you were to do that calculation, you'd find that it's about tripling every 2 years. So that was networking. Storage has its own. Hard disks have been in existence for 70 years. And they've had a consistent, if you look over those 70 years and you extracted, let's say, any particular year, it might be up, might be down in terms of price per bit. But if you take it over the 70 years, it's a straight line and constantly going downwards. Flash memory, which is also semiconductor memory, is semiconductor, follows Moore's law. It's a steeper decline in terms of price performance. And so eventually these lines will overlap. But yes, you're correct. All of these have we call them laws, but really what it is the return on investment of R&D that drives a very consistent improvement in performance over time.
It's funny you should. We're both dating ourselves with technologies that are decades old. I recollect Andy Grove's comment that the laws of physics are the same for everybody. The laws of economics are different. So in a way, most of these laws are really laws of economics.
Correct.
How can you drive costs down and drive higher performance? So in that context, before we talk specifically about Pure itself, do you think that the storage evolution is sort of tracking some of the pace at which the semiconductor-related or networking-related transitions have happened over the years in terms of performance, cost, manufacturability, any number of parameters.
Yeah.
Would you say that they are all tracking similarly?
I would say it's generally yes, with a big caveat though.
Yeah.
And the caveat is that storage is a particularly conservative market.
Yeah.
And so users are less apt to switch to a new technology because of perceived risk.
Yeah.
And the perceived risk is there because if you lose, I guess users are somewhat accustomed to a computer, malfunctioning or not working properly. They like less than that when the network stops operating, but they're kind of used to the network not being perfect.
Yeah.
If you lose data, if one loses data, people get fired.
Yeah.
Because you've lost all these transactions, you can't prove it. Data loss is considered to be very, very bad. And so it tends to drive a much more conservative attitude in terms of trying things that are new, even if proven better, right? So it's a slower moving market. But outside of that, yes, largely they track one another.
The same way.
Yeah.
But in the consumer side, I know that most of what Pure does is in the data center and the enterprise, and you're not really focusing on consumer. Is that a fair
that is
statement?
correct.
But I think from a consumer standpoint, the user behavior, much to what you just said, also had happened in the last 10 plus years. I'm sure both of us remember when, we had to go and delete inbox
That's right.
In our Outlook or in our Google Mail. And at some point we stopped doing that.
Yes.
Because there was, unbelievable unlimited storage.
That's right.
What drove that? Why was there a inflection where people stopped worrying about storage as a limited, constrained commodity for usage?
Well, because when you ran up against the limits of whatever storage you might have had before, it caused a huge number of problems.
Right.
Whether it's the enterprise or whether it's a consumer. Let's go back, and I'll use this analogy maybe a couple of times today. You may remember that even a decade ago, but certainly 15 years ago, if you needed more storage for your laptop or your desktop, you bought an external hard drive, right? And initially, fantastic, you had extra storage, right? But what happens when you started running up against the limitation of that? Well, a big hassle. You'd have to go buy a new one, a bigger one. And then you'd have to move everything you had on the smaller one over to the bigger one, right? And you couldn't easily share it or anything like that. But that was your only choice, right? So I think two things happened that fundamentally answers your question of why things changed. First of all, we all went to the cloud for storage, right? And once you're in the cloud, you don't have to worry about your own device. You also don't have to worry about having a limit. You have a limit as far as what you've paid for. But in a sense, the cloud can have a lot of capacity. And so allowing you to go even further is just a matter of paying, just a matter of economics, as you discussed before. So first of all, it became a lot easier for a user to just add more and more and more. They just had to shell a little bit out of their pocket. The second reason is because of those economics of storage, which has just consistently improved over time to the point where, it's a few dollars a month to pay for your extra storage. And as far as people are concerned, that's a lot easier than the hassle of everything else.
Yeah. So in this context, can you sort of delve into, it's not just more storage, it's not just, cost.
Right.
It's also architectural efficiency, which you keep talking about in some of your speeches and other writings. Talk about what is architecturally more efficient about moving to flash as a semiconductor thing versus hard drives or SSDs or any of that. So talk about why is that difference important?
Well, first of all, almost like every other transition that we've made in the past, when you went from a mechanical system to a semiconductor-based, a chip-based system, right? You got a lot of benefits. You got efficiency. You got cost. You had smaller space, right? And the semiconductor could do more than the mechanical system, which was relatively fixed, right? In the case of storage, flash is simply just much more performant and much denser, meaning more compact, and uses far less energy. Now, the challenge for flash in the past was that it was a lot more expensive than disk on a per bit level, per byte level, however you want to.
Notwithstanding the pace at which Moore's law was driving the cost down in the semiconductor.
That's right. Faster than magnetic was going down, but still higher than magnetic.
Okay,
right. So, and as I mentioned, the lines are approaching one another. It's still a little bit apart, and that's where we are right now. I'll come back to your question. That's where we are right now. We're getting close to the crossover point, and so we're going to see a massive transition eventually
to flash.
Now, the reason for it is, okay, so you get better performance, better density, lower power consumption, and then much more reliable as well, which is very important. Hard disks are mechanical devices. They fail. They fail fairly often. Their annual failure rate is in the 2 to 4% per year range. They almost all fail after 5 or 6 years. So they have to be replaced, fairly often. Whereas at least in the products that we sell, our failure rate is down to about, almost 1/10%. We guarantee them for 10 years. So they last an awful long time. And when you put the full system together, we're literally 1/10 the space, power, and cooling of a mechanical disk system.
So just so for our audience, so hard drive to SSD, which is really flash-based, but it really mimics the hard
disk.
drive.
That's right.
And then there is pure flash,
correct,
which is far more efficient, power efficient, cost comparable to the decline that you're saying in hard drives.
That's right.
But isn't it easier for data centers or enterprises that are looking to moving away from hard drives to go through this intermediary step using SSDs, because that's a faster adoption curve, isn't
That's correct. Well, that's what they've done. And let's talk about this for a minute. The SSD is a brilliant invention, right? Flash works very differently than a hard disk. And we don't have to go into detail, but it works very differently than a hard disk.
Faster read-write,
faster read than write, but you can't overwrite it. There's some maintenance involved. So what the flash manufacturers did 15 years ago, when they wanted to get into laptops, when they wanted to get into computers, they thought to themselves, oh my gosh, if we have to force the operating systems to fundamentally change the way they use storage, it's going to take forever. It takes 10 years to make changes to operating systems. They said, well, we've got a really bright idea. We'll take flash and we'll make it look like a hard disk. Everything. Its form factor is like a hard disk. The connectors are like a hard disk. And there's software inside the SSD to make it look like a hard disk. The benefits being you don't have to change any of the operating system software to use it, right? The disadvantage is the disadvantage you might imagine of making a chip look like a mechanical device, sort of like making a microcomputer look like a typewriter. Does great as a typewriter, but maybe doesn't do anything much else, right? And so when we got started, because we were the first to use flash, we knew we had to compete against much cheaper hard disk. And so he said, we're going to design our own software to make a flash perform at its best possible way, in the best possible way. That's both performance and cost. And so by operating it directly with software, we're able to get about somewhere between a 30 and 40% price performance advantage. So yes, while you're correct that it is far easier to be able to use flash as an SSD in a large scale environment because you don't have to change any of your software. We're now at the point where the economics, the price performance economics with us are so good. And if you're operating at very, very large scale like these hyperscalers, that 30 to 40% makes a big difference. Right? And so we won, as you may know, Meta recently announced that we were the ones they've selected as their next generation, their design for their next generation data center. They can always use the fallback of either disk or SSDs, but their going forward design is going to be focused on.
So I want to unpack a bunch of things that you said here, but I want to get to the software piece that you mentioned, and I want to draw the parallel to what you did while you were at Cisco. Because arguably the Cisco dominance, if I can use
Yeah.
that word, in that period
Yeah.
was largely because of the stickiness that they were able to create with iOS,
Right.
which is the Cisco software stack.
And actually, the definition of the network effect, the very definition of the
The very
network
definition
effect.
of the network effect, but really the Cisco glue
Right.
for across all the switches and routers and all of that
Right.
got enhanced because of iOS.
Correct.
So can you draw a parallel to how you're thinking about software in the storage area
Yes.
akin to that?
You bet. Two different ways. All right. So, method number one, because of all the limitations that existed in hard disks, if you were to go into the enterprise storage market today, what you would find is more than a dozen different software operating systems operating different types of storage. And there are different types of storage, which we don't necessarily need to go into now.
Sure.
But you can imagine high performance, what's called generally cheap and deep.
Yeah.
There are different file formats or block formats. There are large scale
Hot storage,
systems,
cold storage.
hot storage, cold storage, large systems, small systems. And given the way that the limitations of hard disks, vendors would have to create all different operating systems to manage in those different environments. Because we could leverage the inherent performance advantage of Flash, and because we chose to only do Flash and nothing else, knowing that eventually the economics would work across the landscape, we kept ourselves focused on one software environment, one operating system. So every one of our products that really covers that entire space we mentioned, large, small, high performance, cheap, all the different formats of data, we have one operating system that does all that.
And that's called Purity?
It's called Purity.
Yeah.
We call it Purity. So that, first of all, gives us a tremendous advantage because we can focus all of our attention on the one operating environment. The second way, and I'll have to go back to the analogy that I used before of the external disk drive. If you were to go into enterprise storage today, right, so everything except the cloud, and you go into the big banks, the credit card processors, large manufacturing companies, any company actually that manages any amount of data processing in their own environment, what you would find is that the data storage systems that they have, each individual system is tied to an application stack.
Yeah.
Okay? And they might have, several or dozens of application stacks in the same data center, and of course, multiple data centers. And each of those arrays operate as a standalone entity, not networked with anything else.
Yeah.
So these are data silos.
Yeah.
Okay? Independent. And one of them may be filling up. This goes back to that external disk drives. One of them is filling up and one of them is empty, but you can't share the capacity or the performance across them. So you mentioned Cisco. I mean, my network is my background. I said, well, how dumb is this? I mean, why aren't these things? Why doesn't it operate like a cloud of data rather than individual arrays? Right. So instead of that external hard drive, why not take the enterprise? Why not allow them to make their own cloud? Why do they have to go to the cloud to get cloud? Cloud is a way of operating, not a destination. And so with the work that we've been at for 3 or 4 years now, all of our systems are upgradable to just the next latest code where they automatically transform from individual arrays into a cloud of storage.
So it's almost like what you're really saying is the data that somehow got really tightly integrated with the application in which the data is used for.
Correct.
You were sort of decoupling it and creating data as almost like a data lake available in the cloud for all applications and the intelligence shared between all of that. And you're making the point that Flash and your sort of software solution allows cloud providers and hyperscalers to be able to do that.
That's correct.
Now,
well, hyperscalers have been able to do it on their own, right? Because they built that software on their own.
Ground up. But the
enterprises could not.
But so I want to go back to your Cisco days. I'm sorry, I'm trying to do this comparison with Cisco because these are very relevant. And we're going to talk about AI in a second. But, Cisco was very big in cybersecurity and there are a lot of security-related products. From an enterprise standpoint, isn't it more prone to cyber attacks if the data is all completely shared? Because then once that is compromised, every application is compromised, potentially.
Well, it's an interesting analogy. As you know, also if a network is penetrated, right? One of the problems in enterprise networks was that once an attacker is able to get on the network, then they're able to everywhere. They're able to get around to everywhere, right? And so you need to have the same protections regardless of whether the data is also networked, because the data is also accessible. In fact, most attacks against data today are attacks against the application stack that the data is attached to, right? And that's where the leaky bucket is. So I would say that it doesn't fundamentally change the attack profile.
I see.
Yeah.
So let's talk about AI, because I think you're sort of leading to cloud infrastructure and this whole wave towards every enterprise really looking at their workloads as AI workloads.
That's right.
Is there a hierarchy of significance or importance between compute, networking, storage, memory, and power? If you were to take these 5 things,
yes.
I don't want to sort of minimize your role as storage, but is that a tail versus the dog in this thing? I mean, which is the bigger constraint?
Oh, well, so first of all, there's an economic hierarchy, right? Especially now, right? In terms of where economics are being realized, right? Now, and we can walk through that, right? And then each of these things have their own, challenges and opportunities. So let's start with on the chip side of things, the semiconductor side. Clearly, NVIDIA and much more generally GPUs are driving all of the economics.
Well, it's almost like saying that the margin profile is heavily loaded towards the providers of GPUs.
That's exactly right. Now, by the way, that's also very heavily focused on the hyperscalers. I would say between hyperscalers, what's generally called tech titans, companies like X and Tesla, and sovereign clouds are 90% of that market, right? So it's still very strongly felt there. The second economic winner is networking, because all of these systems have to be tied together, and by far the most popular, and I think increasingly so, connectivity vehicle is Ethernet and Ethernet switches, right? So they get a lot there. Much smaller on that scale is storage, and has surprised a lot of people. We were clear on that.
And you would put that ahead of power, energy?
Well, no. So let's come back to power, because I think power. Let's come back to that. But much smaller than either networking or GPUs is storage. It's very surprising to people, but all of GPT-3 was trained on a few terabytes of data, which is almost nothing. We estimate that last calendar year, 2024, the total amount of storage sold into AI was probably about 1.5 billion, somewhere less than 1.5 billion. Now, that's nothing to, I think either one of us would like $1 billion,
that's right.
Even just in terms of additional revenue. But in an overall $50 to $70 billion market, it's still relatively small. Power is going to be a huge constraint, but the estimates that are made as a straight line on where AI is today, I think, underestimates the degree to which efficiencies will be found in AI. One of which, by the way, is I had mentioned that our storage is about 1/10 the space, power, and cooling of traditional storage, that is hard disk storage. In the hyperscaler, if 90% of their storage is hard disk, and about 25%, and this is true, of their total power in a data center is taken up with storage, we effectively give them 20% of their power back. Think of that as a power source.
That's great.
It's a huge power source against all the data centers that are currently in existence. So that's a huge power source. So I think what we're going to see is as GPU power efficiency improves, and as we start switching over to flash, we're going to see that there's less power requirements than which is very good because building power and commissioning power plants and power lines and all of that is a multi-year process and very, very challenging.
Yeah, and you were going to touch on memory because memory is the other piece.
So memory is the other piece. So memory, the challenge with memory, and so memory is a growth business, and that's going to be a very strong business. And part of the reason for that is memory has largely reached sort of the end of Moore's law. Maybe not the end, but it's really leveled out in terms of the kind of improvements. Memory led Moore's law. I don't know if you remember that.
I remember. DRAM was the thing that started the whole revolution.
Exactly, right. Yeah. And so that was really what led the doubling every 2 years. And that's flattened out a lot for a variety of reasons. So increases in demand for memory is not going to be met with decreases in in price as we go forward. And that means a strong growth business there.
So I want to touch on another common friend of ours, Sanjay Mehrotra, who's been on our podcast in one of our earlier episodes. He's the CEO at Micron, and prior to that, he was the CEO at SanDisk.
Correct.
And
and I don't know if you knew this.
Yeah.
That we were lab rats together in
I am aware.
Graduate school.
That's why I brought this up because. So he, built SanDisk as a sort of a storage story with Flash, and then he made the choice of selling himself to a traditional hard drive provider.
That's right. Yeah.
Which a lot of us in the industry were scratching our heads as to how does that make sense.
Right.
But it sounds like Western Digital is splitting.
They just split. Right.
They just split between Flash and the traditional hard drive business. Right. And the reason I bring this up is this question related to the data center, where you have compute, the GPUs or acceleration CPU class engines that power it. And then you have a HBM, high bandwidth memory activity, which is what Micron is all about.
Right.
And then you have storage.
Yes.
So not to put you on the spot, but is there a scenario where the storage providers think of consolidating with memory because it also offers significant benefits to the large hyperscalers to see that as being a consolidated offering for a variety of reasons, including benefits in power and all of that. Yeah. So your thoughts on that?
Well, it's an interesting conversation. And as you may know, just last week, we introduced what we believe is going to be the world's fastest storage system for AI environments. Yeah. Right. We'll beat the current set of benchmarks by a factor of 5 or 10. Yeah. So very exciting.
When you say fastest, it's largely latency and access.
No, it's actually speed of being able to deliver data. Okay. Okay. So GPUs are
notorious
for sucking, needing to suck in, but also write a lot of data very, very rapidly, right? Yeah. So the faster you can get the data to it and the faster you can write the data from it, that's what delivers most of the value add in those environments. Right. And of course, on the computers themselves, they have this high bandwidth memory, which is extraordinarily expensive. Yeah. So there's this constant tug of war between how fast can you deliver the data from a less expensive storage system and how much high bandwidth memory do you need? Yeah. So for that reason, it turns out as well that the semiconductor manufacturers, you mentioned Micron, SanDisk, which is a portion of Kioxia. Yep. They produce both. Yeah. Right. And for a company like us, we're always trying to enable the customer to get the best economics by producing our product to be able to operate faster, so that they need less high bandwidth memory. Yeah.
So in a way, you're saying that if in situ, if memory was there, and if you can deliver, much faster access, much faster read and write in memory, in storage, you're stealing from the memory opportunity.
That's right.
Right?
And by the way, this is classic. This has always been the case. Yeah. There's always been this battle between the speed of storage and the need for more and more memory. Right. And for that reason, in a sense, we're in the business, but I think it'd be unusual to find a company that will compete in both, especially since high bandwidth memory is sold to the computer manufacturer, which is storage is sold to the customer.
Right.
And so it's a different customer.
But that blends in the data center, though.
It does.
Right.
Well, you're correct about that.
Right. Because the data center wants to have access to, if I have the NVIDIA GPUs, I want access to a lot of HBM and I want access to a lot of flash storage as well.
That's right.
But let's talk about AI in this context and data, because you brought that up as the opportunity to sort of decouple application-specific data to more of a horizontal data lake.
That's right.
That's a huge opportunity.
Yeah.
But
I wouldn't call it a data lake because that has a particular
I understand.
meaning. Yeah.
That was
I'd call it a data cloud.
Data cloud is data lake is more in the database context, and that's different. But I want to ask you this question about training, AI training, and inference.
Yeah.
And there's this move towards slow thinking, slow reasoning models in inference versus, fast thinking, GPT-4 kind of instantly give me a result.
Yeah.
How does that affect you when you're talking about much better performance and being able to offer you the solution very quick? Doesn't that fly in the contrast of what you're saying?
So now we get into the intricacies or the complexity, if you will, of the AI market.
Yeah.
Right. You might remember that I said that my view of the total market that existed for storage in AI last year was less than $1.5 billion. Right. And it's because of the reasons that you're identifying, which is the developing the models. AI and machine learning is really mostly being done by these by the hyperscalers, the sovereign clouds, and the tech titans, right? Nearly all other companies, with a few exceptions, are going to be focused on inferencing or retrieval augmented generation, which requires far fewer GPUs. And does not require this extraordinarily fast storage, right? So in my view, the real opportunity, for us is in something quite different, which is if you were to go to most enterprises who have been studying how they are going to use AI for their own benefit, what they would tell you is that their data storage or their data itself is so fragmented around the enterprise, they don't understand how they're going to get access to it and pull it together to pull insights out of it. And this is why our concept of aligning their various different types of storage into something that looks more like a data cloud gives them that access to the data and will make it easier for them to be able to access it. And so I believe that's the big opportunity in the enterprise is more along the lines of organizing the data, making it accessible, eliminating the silos, and doing one other thing as well, which is creating more uniformity. This data cloud that we're creating allows customers to create rule sets around how data is handled, and to do so in an automated fashion rather than manually. With pen and paper. And so it enhances cybersecurity because the data is managed the way that they set by policy and software. And at the same time makes the data accessible to, whether it's analytics or we don't even have to talk about AI per se. Any kind of analytics or data analysis, even AI, it makes it more accessible.
So I want to just create a mental model for my own self and perhaps for the audience. So in a way, the software architecture that you have, maybe it's Purity.
Purity,
is akin to what Jensen is trying to do with CUDA, although it has different purposes.
Correct.
It enables a whole class of developers to write to, his GPUs and stuff, and akin to what Cisco was doing with iOS in a way. So is that the mental model?
Yes. In fact, I might even employ another one. So, one of the things that you mentioned Cisco, one of the things Cisco did was effectively virtualize communications. Right? It no longer, everything used to have its own communications network, and then it became one thing, right? So it was virtualized. Well, another company and technology that virtualized something was VMware, of course. Okay.
I was going to get to that.
Okay.
Yep.
And it virtualized compute.
Yep.
You may remember vCenter.
Yep.
So in addition to VMware saying, well, you could run more than one application, more than one environment on a machine, you became a virtual machine. What vCenter did is it said, okay, now you have all of these virtual machines. We'll make it easy for you to run an application on any one of them and to manage where the applications are operating, right? That's what we're doing with Purity, is that it's like vCenter in the sense that now data is managed in an automated fashion rather than manually. And you could classify different types of data to be managed in a different way, and again, have that happen in software. And so it's another strong analogy.
So it strikes me when you say that. I was going to get to VMware and virtualization, but in the storage context, you can talk about containers.
Yes.
Kubernetes or Anthos, what HPE was doing. And it strikes me that Google came up with Kubernetes.
Yes.
And HPE came up, who was one of your competitors, came up with Anthos.
Yes.
In sort of virtualizing container technology. And you bought Portworx.
We bought Portworx.
So talk about that. How important is that for your core strategy of building virtualization from a storage standpoint and containers?
Well, actually, I'll go into just a little bit of detail around containers. Because containers is another virtualization technology, but it's even one layer lower, if you will, than a virtual machine.
Right.
And containers in Kubernetes was designed so that applications could scale very rapidly and then descale, if you will, or get reduced also very rapidly. And when that happens, you have to set up connections to storage very rapidly. And so it operates very differently than the way the world operated before that. Generally, storage systems were tied very, very closely to their application. And it didn't change very often. When it did, it almost always changed manually. Now, in milliseconds, you want it to go up and down. And that's what Portworx does. What Portworx allows is for applications to scale.
For our audience, Portworx is a small private company that you acquired.
That we acquired some years ago. We saw that the world would over time, I think very few people would argue that 10 years from now, applications will all be containerized. Today, they're mostly all virtualized.
But if they're containerized, is it orthogonal to what you said about data cloud, or is it in the data cloud there are many containers per application?
Well, containers are are focused on the compute side of things. Okay, so it's containers virtualize compute and applications. It actually is orthogonal to the data cloud, right? And whether or not you even have a data cloud. You can still just have one array tied to a container stack. But the fact that you want something to be virtualized on containers, in my view, is you also want your data virtualized so that it doesn't matter where your data is. You don't want to be constrained by where it happens to be.
This is all, quite fascinating. We can keep talking about a lot of the technology elements of it. I mean, you seem to have really identified the possibly the next great innovation and explosive sort of use in the data center, in the storage area. But you have a lot of competitors, Dell and HPE. And so talk about who do you run into all the time?
Well, Dell is by far the 800-pound gorilla, right?
But they came from the compute side.
They came from but they bought EMC, which is how they got into storage, right? And EMC was the 800-pound gorilla. Now, because they started, and still really their legacy is from the hard disk. In their case, they have 9 different operating systems for all the different types of storage that are out there, which I think is quite constraining. And another thing is just their business model is much more of a commodity business model. And in fact, when I joined Pure, the dominant consensus was that storage was a commodity area and was going to either go to the cloud or become completely commoditized. And my view was it's one of the 3, we talked about this right at the beginning, it's one of the 3 major areas of spend in the data center. In fact, usually it's the second largest area of spend. And for data centers to continue to advance, it has to advance. If you treat it like a commodity, there's an opportunity for someone who treats it like high tech.
Yeah.
To give you a sense, we will spend, even this year, we're, as you know, over $3 billion now, publicly traded company, very profitable. But we'll spend 20% of our revenue on R&D this year.
Great.
Many of our competitors spend less than 5%.
Yeah.
Because they treat it as a commodity. So it's a very different point of view.
But to your point that Dell had EMC, HP is your competitor also.
Yes.
And these are your 2 largest competitors.
And then NetApp, who's also very large. Yeah.
Very large. But in the case of at least an HP and Dell, they have a core business which is much larger in the compute side. So do you worry about the fact that for you it is just storage? And I understand that you don't want to make that, at least have your customers perceive it as a commodity. But for the other guys, they have other margin pool that they can sort of aggregate storage with and go to market faster. Yeah. Is that a concern of yours?
Well, it's always a concern in the sense that one of their selling techniques is to sell what they call full stack. Meaning we'll sell compute, storage, and networking, although neither one is terribly strong in the network.
Well, which is one of the reasons why HP tried to acquire Juniper.
Juniper, that's correct. Right. And it's still attempting, I think.
It's still attempting. Yeah.
So that is a sales technique. But I think that, first of all, you have to realize that compute, in a sense, is a terrible business.
Yeah.
It's the semiconductor companies that make money.
Not if you're NVIDIA.
If you're the semiconductor manufacturer, Intel and now NVIDIA, you make a ton of money.
Yeah.
But the assembler or the manufacturer of the server is in terrible shape.
Yeah.
It's a terrible business. So they're interesting, I think, for both HP and Dell. Their top line is driven by compute, but their bottom line is driven by storage.
Interesting.
And so it puts them, I think, also in a challenging position. I think the fact that on the compute side they spend almost nothing on R&D, it hurts them from the attraction of good engineers on the storage side.
So let's just, in the final section, let's just talk about Pure a little bit. The company went public in 2015. It's over 10 years now.
That's correct. Yeah.
And you started in 2017.
2017.
So you've pretty much seen this explosive growth of Pure.
Yes.
So do you see this continued growth forward organically? Do you see yourself doing some inorganic moves? And if so, in what kind of areas would you think about it?
So yes, it's been nearly all organic. 20% of R&D is a lot of
capital.
Is a lot of investment. We are very active looking at opportunities for inorganic. Yeah. But even there, we're looking, I would say, largely for technologies that help us in this march towards the enterprise data cloud vision, right? Which is really more around managing data than it is adding storage. If part of our value is that we satisfy all of the customer's storage needs with one operating environment, you can't buy another storage company, right? If you do, now you have two completely different environments, and that reduces, if you will, the value and the attractiveness of what you called iOS, right? Of the ecosystem, right? So we have to stay very focused on being able to complete the entire storage set of capabilities with one operating system. Yeah. Now, in the area of making it look more like a cloud and data management, that's an area that's ripe for adding more capability and value.
Yeah, I would have to assume that you're probably trying to go up the stack and not just be thought of as a storage provider, but you're actually providing some degree of full stack, maybe security, maybe manageability, and all of those.
All of those things. If you think about it, once we complete this idea of a data cloud of storage, then it's all about managing the data on top of it. And that's what's really exciting. You can't manage the data on top of it if you have a different system for every different type of storage. Once you virtualize it, to use that phrase, now you're managing the data on top of it. Or now we provide the tools for our customers to manage it.
So on that data point, the last point on the data point you made, in the AI landscape, in inference, there's all this talk about peak data and moving into sort of synthetic data and all of that, in creating new data for training and inference. Right. Do you have a point of view on where that leads and how that can be helpful to you?
I do. My view is that more than than anything else, customers want to build models on created data. Or let me rephrase it. Models will create data that is the fundamental rule set for the model. After that, what they want to use is as real-time data as possible, as well as historical data to come up with insights.
Yeah.
So it's really more a matter of organizing your own data environment to be able to gain insights.
Yeah.
Yeah.
It's interesting you say that because, as you know, Celesta invests in lots of companies in deep tech, and some of our companies are actively engaged with your team.
Yes.
And,
Yes,
Platform 9 is
Correct.
Very involved with the whole VMware replacement opportunities, as is Weka, which is working very closely with your team.
Yeah.
So, we're all rooting for you to go all full stack because I'm sure they will find lots of opportunities to look at in our portfolio.
Oh, thank you.
But let me just, finish in the last section. Charlie, you have been a very understated executive, but just had an amazing track record of achieving and riding some very crucial waves. Where does this wave lead you to? I mean, do you see yourself sort of continuing in the storage landscape and evolving Pure into a much larger business? And what's your what does the next 5 years look like?
I do. The next 5 years, honestly, as you point out, I'm not a spring chicken anymore.
Well, notwithstanding the gray beard and the professorial look,
Right.
I sort of think of your energy. You're an avid skier. So
I am. I know. I live to ski.
I think a lot of spring chickens will compete with you.
Yeah, well, I can compete with a lot of them. That's actually true. But no, I'm fully committed to driving these. I'm very mission oriented as an individual, right? And the missions I really want to complete right now is driving this capability for enterprises to create their own enterprise data cloud rather than these silos, right? That's a multi-year mission. The second one is, I mentioned the win at Meta.
Yeah.
I do believe that 5 years from now, all of the major hyperscalers could. Now, I don't know that we'll be able to achieve all, but a significant fraction of the major hyperscalers will use our technology to replace their existing storage environment. Right. Maybe not exclusively, but to a large extent. And honestly, I think as we get older, we really enjoy developing people as well.
Yeah.
And so developing the team here at Pure to really lead or to be the leaders of a leading company.
Yeah, that's fantastic. Yeah. You've also been very active in investments. I mean, you ran a big chunk of the Cisco investment. You were at Silver Lake. You drove, I guess, the Skype acquisition.
Skype, it was myself and one of my partners. Yeah.
So does Pure have lots of investment activity around your?
We're just getting started in that area. Good. Yeah. We put in an investment in CoreWeave.
Yeah.
We have a small investment in a company that's pursuing alternatives to tape, as it turns out. Which continues to be an important area for data storage. Yeah. And then we're looking at other investments as well. So no, we will continue doing that. I would say that my full-time job here has probably caused me to curtail some of my personal investment activity. I just don't have as much time to pay attention to it.
Well, Charlie, this is just truly fascinating to talk to you, and I've always admired your career and your journey and all the things that you've done, and really thank you for the opportunity to sit down and talk to you about what makes the storage landscape important for the data center and the role that Pure plays in that. So thank you for joining this podcast.
You're very kind, Sriram. It's always been a pleasure working with you. I remember our first meetings over at Intel.
This was in you and I battled a lot of issues around Wi-Fi.
I was just thinking that myself. We really did. The early days of Wi-Fi.
Yeah,
which,
today we take it for granted, but you and I know some battle scars from that period.
We absolutely do. Yeah.
Well, thank you so much, Charlie. I really appreciate you joining us. Thank you.
Take care.
Thanks for tuning in to the TechSurge podcast from Celesta Capital. If you enjoyed this episode, feel free to share it, subscribe, or leave us a review on your favorite podcast platform. We'll be back every 2 weeks with more insights and discussions on all things deep tech. Thank you very much. Bye for now.